This is one of my absolute favourite kinds of tasks because it never fails to get pupils engaged and it always gets them thinking mathematically. It's also a really versatile kind of task template because this is just one arrangement of dice, but you can make up your own patterns, and the idea is you just get them to either find out how many spots are in the image or which colour dice has the most spots, or if you're doing maybe a statistics lesson you might say what's the mean number of spots. So it's really versatile and can be used in many different ways. So, gut instinct first. Which colour do you think has the most spots? And then when you're ready, try and calculate it using a systematic strategy. So, the gut instinct is likely to be either the greens, blues or yellows. Pupils will often say it can't be the reds because although they're worth the most, there's only 4 of them. There's only 4 sixes. And a reverse argument for the whites, there's loads of whites around the outside, but they're only worth 1 each. So the green, blue or yellow sounds sensible. And then we say, okay, how can we actually calculate these? So one way is to consider the fact that all the patterns are basically like concentric squares, aren't they, going in on each other? So each square has 4 sides. So let's work out how many are along the top row. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 along the top row. But you can't just do 12 times 4 because that last dice is the start of the new row. So you can do 11 times 4. 11 times 4 tells you how many white dice there are. So let's write that down. So we've got 4 lots of 11. And each of those dice are worth 1. Because they've got 1 spot on them. So that'll tell us, that's a calculation for working out how many spots are on the white dice, which is obviously 44. And if you want to, they can actually check this by going down and counting them individually. Now, what about the 2 dice, moving on to the black dice then? Well, how does this 11 change? And how do the other numbers change as well? Well, the 1 was the value on the spot, so that's going to move up to 2 because we're counting 2s this time. It's still arranged in a square, so this 4 is going to stay the same, but this 11 is going to change. Because instead of a strip of 11 going along the top now, we've got a strip of 9, if we're going to split it into sort of four lines. So we've got 4 times 9 times 2, and at this point, pupils will start to spot a pattern, how we can calculate these systematically. So 4 times 9, 36 times 2 is going to be 72. What about the next one then? Well, hopefully they've realised by now that these 4s are going to remain constant. So there's going to be 4s all the way down these calculations, and it's these numbers that are going to change. Now this has gone from 11 to 9. On the next one, what about the 3s? Well, you can see you've got a strip of 1, 2, 3, 4, 5, 6, 7. We're decreasing by 2 each time because basically we're effectively losing the corner dice each time, aren't we? And this time we're looking at the 3s, so we're multiplying by 3. And at this stage, most pupils will be able to complete the rest of the calculations by looking at this sort of systematic calculations we're doing and figuring out that's going to go 1, 2, 3, 4, 5, 6, and this is going down in 2s. 11, 9, 7, 5, 3, and then 1. And then can they explain each of these calculations? Well, that last one here, for the 6s, there's 4 lots of 1 dice, and each dice is worth 6. So it holds. So let's work out these out then and see if we notice anything. So for the second one, we've got 28 times by 3, which is 84. And then we've got 20 times by 4, which is 80. Then we've got 4 times 3, 12, we've got 60. And then here we've got 24. So which colour dice has the most spots? It's this one here, the 3s. So I mentioned that I like this task for its versatility, and the calculations you just saw are something that might just naturally arise during a year 7 or a form time. But if you've done more advanced maths, then you can make some nice links with difference of 2 squares as well. So for example, consider these 1 dice around the outside. Imagine if the whole diagram was just 1s. Well, you'd have 12 squared, because it was 12 by 12 square, you'd have 144 1 dice. Now obviously then that's not the case. We need to subtract all those dice in the middle. And those 2 dice, if you have a look, that would make a 10 by 10 square. So 12 squared minus 10 squared, which is where the difference of 2 squares comes from, tells us how many white dice there are. You can see 12 squared minus 10 squared is 44. and each one of those is worth 1, which is the same answer as we got before. It's just a different way of calculating it. Then, what about the black dice then? Well, if the whole image was just black dice, it'd be 10 squared of them. Then we need to subtract all the middles. And this time it's the greens we're looking at, which is an 8 by 8 square, so subtracting 8 squared. And this time they're all worth 2, so we multiply them by 2. So you can see we've got another nice pattern emerging here as well. So it's just going to go down in 2s each time. So 12, 10, 8 squared, 6 squared, 4 squared, 2 squared. And then we subtract the middle square. Remember that difference of 2 squares. So it's going to be 6 squared, 4 squared, 2 squared, and then 0 squared. And that 0 squared, obviously we don't need it, but it does make sense with our systematic working that we're doing. And then times by 3, times by 4, times by 5, times by 6. And to be fair, you could come up with this calculation during a Year 7 lesson. You don't necessarily have to mention difference of 2 squares. But if you have done it, then you can say, is there another way that we could maybe write this calculation? Well, 12 squared minus 10 squared, we know we could write as 12 plus 10 times 12 minus 10. And we can physically work these out because there's no x's involved with this, it's all just numbers. So we can do 22 times by 2, which gives us that 44 that we wanted, so 44 times by 1. And the nice thing is we can work out all of these expressions quite quickly because we know the difference between the two squares. This difference here is always going to be a constant 2 because it's going to be 10 minus 8 in the second brackets, then 8 minus 6 in the second brackets, and so on. So essentially we just need to add these two together and then double it. So 10 plus 8, 18, double it 36, times it by 2 gives us the 72. 8 plus 6, 14, times it by 2, 28, and then times it by the 3, and so on. And we get exactly the same answers. It just shows, it's just a nice way of linking it to the difference of 2 squares. So, if you've got any other ways of calculating the number of spots, please do let me know, and hopefully you've enjoyed this.